We've talked about graphing inequalities, and we're going to see it again today. But before we get into graphing of inequalities, we're going to see some compound statements today. And what we mean by that is that we're going to have like more than one statement. And there's a couple different ways that you're going to be seeing that. Now, before we get into the inequality part of it, we're going to talk about a little bit with what is a compound statement, what would it look like with or without an inequality. And I'm going to show you a couple of examples of where we might see this without an inequality, and then obviously we'll do some with an inequality as well. Okay, we've talked a lot about sets. And before we get into equality, we're going to talk about two different kinds of sets. We can talk about what we call an intersection, or we can talk about what we call a union. An intersection is going to use the word and, okay? Because if we want both things to happen, if I want this and this to happen, that means I want both things to happen. Okay? Union is or. I want one or the other to happen. Okay? I always kind of use the example of like going to a birthday party and you got ice cream and cake, and you could have ice cream and cake, or you could have ice cream or cake. I'm an and kind of guy. I like them both. So I know I don't look like it, but I do like both. So, but it's different, right? It's different because one where you're getting both. One you're going to choose and you're going to pick one or the other. And so when we talk about doing it with sets, I'm going to give you two sets, and we kind of talked about sets earlier in the chapter, or even maybe it is even a little bit in chapter 1. Bless you. Okay, so we have two sets. They're enclosed in some brackets. And if I said what numbers are in A and B, and the way that I'm going to read that is A, and then this symbol right here means and. So instead of having to write the word and in there, sometimes we'll see that symbol. It kind of looks like an N. And so I remember N and kind of going together. It's not really an N, it's just a symbol, but we read that as A and B. And so when you see that symbol, we're going to ask what numbers are in both A and B. And so 3, 4, 5, 3, 4, 5. Those are the three numbers that show up in both. And so my intersection here would be 3, 4, and 5. Bless you. Okay, for the union, I'm going to use the same two sets. This time, our symbol is going to look a little bit different. It's just the upside down. And once again, it kind of looks like a U. So I think U for union. But we read this as or. What numbers are in A or B? And so they could be in one or the other. Now, some of them are in both, right? But we also want the numbers that are included in either of those two sections. So when we have an or statement like this, then typically we're going to have a bigger set, right? We're going to have more things included. So anything that's in either one of these. If it repeats, you don't need to write it twice. You're just including it, right? So we're going to go 1, 2, 3, 4, 5. I'm going to list everything from set A. And then over here, 3, 4, 5 repeats, so I don't need to include those again. And then we're going to add 6 and 7 to the end. And that would be our or. Okay. So that's just kind of showing you what and or will do without an inequality, and kind of showing you the difference between the two. The majority of what we do today is going to be dealing with inequalities. And this one I know doesn't have an inequality in it, but it really just shows how an and or are different. Okay, we're going to look at some intersection examples first. I'm going to start off with a real basic one. X is greater than 2 and X is less than 8. Okay, last week when we wrote our answer, we wrote it in 3 different ways, right? And I'm going to put that up here again today because we're going to write our answer in the same format today. So on a lot of your homework problems, the first thing we're going to do is we're going to write it in set builder notation. We're going to write it in interval notation. And then we're going to graph it on a number line. So if I just simply asked you what numbers are bigger than 2 and also less than 8, what would be some numbers that would work? 3, 4, 5, 6, 7, okay? What about like decimals? Would like 3.5 work? Yeah, okay. So anything bigger than 2 but less than 8 would work, right? Now, I almost think when I do this and look at my 3 different options of writing my answer out, I usually like to go to the graph first, and I'll show you why. I'd like to go to the graph first. This is just the way the book is going to write it out, and so I write it out like this as well, just so you can see what it's going to look like, but you don't necessarily have to do it in that order. Okay, and if you want to do it in that order, you're more than welcome to do that. But I like to graph it first so we can kind of put the numbers on the number line that we are going to look at. Okay, so 2's down here, 8's down here. And now here's the part that we have to remember from last week. When we do graphing, from here on out, we're not doing closed circle, open circle anymore. We're still using our parentheses and our brackets. Okay? So greater than 2 means we're not including 2. So there's going to be a parenthesis on 2 going to the right. 8 x is less than 8 means we're going to have a parenthesis on 8 going to the left. So what this is going to look like is everything from 2 to 8, parentheses on both sides. They're going to open up towards one another. Everything in between. Okay, so all numbers between 2 and 8 would be included here. Fractions, decimals, 3, 4, 5, like we said, anything between those two. If this was an equal sign right here, then we would have used brackets. Okay, but there's no equal sign, so we use parentheses. Okay, then when I go up here to my interval notation, x such that, and then here's how we're going to write it. With an and statement, we can kind of combine these two together and rewrite it like this. If you wanted to, you could do it like this and write it separately. And some people probably would prefer to write it like this, but it takes a little bit longer, right? It's a little bit more writing to get there, whereas this is combined. And all we're saying here is x is between 2 and 8. 2's on the left, 8's on the right, x is somewhere in between those. Now notice I did change the sign here, because here it said x is greater than 2, but if I just cover this up, this is saying the same thing, right? We just put x on the right, and we put it between the 2 and the 8. So you kind of rearrange everything and just say x is between those two. When you have an and statement, most of the time, ands are going to meet in the middle. Okay, you're going to have an end on either side, and they're going to meet in the middle. And then finally, if I write my interval notation for this one, another reason why I like to do my graph first is now I'm going to start at the parenthesis at 2, and I'm going to go all the way over to 8, close it off with another parenthesis. If I have my graph, that makes both of those, I think, a little bit easier to do and a little bit easier to answer. Okay, questions on that one? Okay, I'm going to show you a couple of different ways that ands are going to be written out. We will see some like this. 3x plus 1 is greater than 2, and 2x plus 4 is less than or equal to 14. Okay, the first one was pretty easy because it was already solved, right? We didn't have to get x by itself or do any work to get there. This one, we have to do a little bit of work to solve it. So I'm going to subtract 1. And then divide by 3. Okay, and sometimes we'll get some fractions, and it's just going to be what happens. And I know we like to end up with nice integers and whole numbers most of the time, but that's not always going to be the case. Okay, over here, we're going to subtract 4 from both sides. 14 minus 4 would be 10. Divide by 2. X is less than or equal to 5. Okay, then our three answers, once again. I'm going to go down to part C. And you don't have to be real specific on the number line. I'm going to put 1/3. Just make sure the number that's smaller is to the left. The number that's bigger is to the right. Think about how a number line is set up. We wouldn't want to put 5 here and 1/3 over here, okay? Because that would be putting them in the wrong spots. Okay, so we're greater than 1/3. And there was an and statement in between here, so keep that in mind. But we're not including 1/3, so it's going to be a parenthesis opening to the right, because it's going to go bigger, greater than. Hey, now here's where it's a little bit different. X is less than or equal to 5. Okay, what kind of symbol do we want here? Bracket, okay? And it's less than, so it's going to open left. And then once again, we're going to shade in between. And like we said before, majority of the time, okay, it's not always true, but majority of the time, ands should meet in the middle, okay? And if they meet in the middle, that tells us probably that we're doing something right. Okay, when I write my set builder notation here, it would look similar to that. X is somewhere between 1/3 and 5, including 5, because it could be equal to 5. And then if I put my interval notation down here, parenthesis on the left, starting at 1/3, going over to the 5, including that. Okay, so that is just, the only difference there is we had to solve it a little bit. We had to get x by itself, do a little bit of work to get to the inequalities, and then we were able to do everything else the same. All right, one more and problem. This one is written out a little bit differently. So this one's going to be the hardest of the three. We're still trying to get x by itself. But this is considered to be an and statement. If there is no word written in there, then we always assume it to be and. Okay? And so sometimes there may not be a word written in there and said this is an and statement like the last couple were. So now we know this one to be and. And basically what we're doing here is we're saying negative 9 is less than or equal to negative 5x plus 11. And then we're saying negative 5x plus 11 is less than 21. So I could write this out as two separate inequalities if I really wanted to, but I'm going to show you a shorter way to do it rather than doing all that. And I think it's a little bit quicker, it's a little bit easier to do it this way. So our goal is still to solve for x, right? We're always saying we got to get x by itself. If I have negative 5x plus 11, what would I typically do first? What would I do to get x by itself here? Subtract 11. Yep. Now here's the trick. Usually we do it to both sides of the inequality, right? But we have three parts to the inequality here. So we're going to do it to the left, the middle, and the right. All three parts. So this gives me negative 20 is less than or equal to negative 5x is less than 10. Okay, still don't have x by itself. So now our next step would be divide by negative 5. Okay, and here's another thing that we got to remember or keep in mind. We talked about this last week. Anytime we multiply or divide by a negative, the sign has to flip. Well, here we have two signs, so that means all my signs are going to flip. And so it's going to kind of look like that. Okay? But some weird things are going on here, right? 4 is over here, negative 2 is over here. So what I'm going to show you here is I think I would rewrite this. I'm going to put negative 2 here. I'm going to put 4 here. X is still going to stay in the middle. But like right here, we're saying x is bigger than negative 2. So we want the sign pointing towards the negative 2. And we're saying x is less than or equal to 4. So what we did was we just flipped everything. X stayed where it was at, but we just flipped the inequality around. So that way, we always want the smaller number to be on the left. We want the bigger number to be on the right. If you leave it like this, I'm telling you right now, what the most common mistake on something like this. When you solve it like this, I'll see this sometimes. Okay? But that didn't make any sense, right? If we have a number line, the smaller number always has to be on the left-hand side. You can't put 4 on the left and negative 2 on the right because that's not a correct number line, right? That's never going to happen. Negative 2 will never be bigger than 4. So we got to put negative 2 over here. We got to put 4 over here. And that's why it makes more sense to rewrite it like this, I think. Okay? If you can write it like this and graph it correctly, then I'm okay with that. But I think it's a little bit easier to think about it like this. Okay, and then once again, all of our work here is the same as what we've done. Parenthesis open and to the right, bracket open and to the left, and shade everything in between. Okay, so now, part A. We're saying for all x values, we're just really taking our statement right here and putting it into our set builder notation. Okay, and so that should be pretty simple. And then for our interval notation, we're just using our graph. And this should be a parenthesis right here. So we're going to say parenthesis, -2 over 2, 4, including 4. And that'd be our interval notation. Okay, questions about the ands? All right, I'm going to put a couple of examples up here of some ors. With an and statement, I could plug in any number between -2 and 4, and it should work in that original inequality. Like, for instance, 0 would be a really easy one here. -5 times 0 is 0. 0 plus 11 is 11. 11 is between -9 and 21, so it works, right? So that's how we could check these. So we're going to do some union problems with the word or in them. We'll start out with a real basic one. X is greater than 2, or X is less than or equal to -1. Okay. So we're going to have 3 parts. Now, we don't have any solving here to do, so we're just going to go ahead and go to all 3 parts. We got -1. We got 2. Hey, and here's what I like to kind of think about. When I see or, most of the time, ors are going to go opposite. So you think, oh, or and opposite. Kind of a trick to remember. That's not true 100% of the time. Okay, but a majority of the time, that will be true. And that's how we know that, okay, ors are going away from one another. They will not intersect one another. Ands come together and they meet, whereas ors are going away, or opposite directions. Okay, X is greater than 2. We want a parenthesis at 2. We're going to go to the right. X is less than or equal to -1. Would be a bracket at -1, going to the left. These two never intersect one another. Okay? Once again, I'm going down to the number line first because I think it's the easiest thing to do. When I write my interval notation here, as we talked about on the last one, we're really just copying down our statement into interval notation. Okay? So that part shouldn't be too big of a deal. We're just putting it into a set. But because we've got our graph here, how far to the left is this graph going to go? Negative infinity. Okay, it's going to keep going forever. So here's the part that's a little bit tricky. We're going to go from negative infinity all the way up till we get to -1. And there's a bracket there. Okay, and then there's a gap, right? We're missing out on some numbers here. And so here's where we put in that symbol we talked about at the beginning, that little U symbol, union for U. And then we're going to start over at 2, and we're going to go to forever, from 2 to infinity. And that would be our interval notation. Because these two are not meeting, then we can't connect the interval notation together. We're going to basically have 2 different parts to it. Okay, and I haven't really talked about this today. And so they're still able to be checked. Same thing for ors. Okay, but here's the difference about or. We're saying anything less than or equal to -1 is going to work. But it doesn't have to work for both. Like here, -2. -2 is not bigger than 2. Doesn't have to be. It only has to work for one or the other. It is less than or equal to -1, so it works here. A number like 3 doesn't satisfy this one, but it does satisfy this one. Okay? So when you think an or and you're checking it, it only has to work for one or the other. Doesn't have to work for both. So you have a lot more options, usually, when you have ors than when you have ands. I'm going to throw you kind of a little bit of a curveball here. This one's an OR, so it's got to stay separate because it's an OR. And we're going to solve both of these individually. With ORs, you'll never see a combined inequality like we did with the ANDs that one time. So here we just have to solve for x individually on both of these inequalities. So over here, we're going to subtract 5. Bless you. Okay, and then we're going to divide by -3. And once again, anytime we multiply or divide by a negative, that sign must be flipped. That's it's an easy mistake to make because we get in the habit of solving and we kind of get in a hurry sometimes when we're solving and we forget to check or remember that dividing by a negative is going to make that sign flip around. So that's really, really important piece you got to pay attention to. You won't flip your sign on every single problem. And that's the other reason why it's kind of hard to remember because the times that you do it, it doesn't always happen. All right, so then on the next one, we're going to subtract 5. Divide by -3. Okay, so this one's kind of a tricky one, okay? We have an OR statement. We're still going to do our 3 parts. Make sure you put -4 to the left, right? Because it's smaller. -4 is smaller than -2. So that's the first part you got to really, really careful of. Just because this is the inequality on the left doesn't mean -2 just comes right down here. Okay? Which number is smaller? That's the one that goes on the left. Okay, let's start here at -4 since it's on the left. What direction is x greater than -4 going to go? Left or right? It's going to go right, right? And so I'm going to graph it. I'm going to put a parenthesis and we're going to shade it to the right. Okay, -2 is less than or equal to -2. So it's going to be a bracket and it's going to be shaded to the left. Okay? And you might say, well, we saw one of these already. We did, but in that case it was an AND. And ANDs were everything in between, right? But this is not an AND, this is an OR statement. So what numbers do you think are going to work here? Everything, okay? Because if I picked out a number like 0, you might say, well, 0 is not in the overlapping region. It doesn't have to be, because if I tried 0, okay, is 0 bigger than -4? Yeah. And remember, it doesn't have to satisfy both. It only has to satisfy one of the two, okay? And so how would we express our answer here? Majan, what do you think?
I'm not sure.
Do you even know the question?
No.
Okay, it's kind of hard when we're talking, right?
Yeah.
Okay. Caleb? Eli? Infinitely many. Okay, and how do we write that? All real numbers, yeah. Okay, and you could do either one. Okay, so up here, I would say x such that, and using some of the symbols that we have used throughout, x is the set of all reals, or I could even write out the word all reals. This is the symbol for all reals, or you could actually just write out all reals, all real numbers, okay? Everything works. How do we write all real numbers in interval notation? What do you guys think? What do you think, Ryler? Yeah, okay, you're exactly right, except we don't need to use brackets because can we ever stop like at infinity? No, infinity goes on forever, right? So we always want, whenever we do infinity, we always want parentheses. So there will always be a parenthesis next to infinity or negative infinity. You'll never put a bracket next to either one of those because you can't stop. Infinity is not an actual number, right? We just know it keeps going forever. So that's why we can't put a bracket there. Okay, so that's one kind of weird different scenario. Just because they're overlapping, we got to pay attention to if it's and or. We saw sometimes if I gave you one like this, and if I said x is greater than 2 and x is less than -3. And you could get this like after solving it, right? But if I just gave you something like this and I said, let's graph it. -3 is down here. 2 would be up here. Parenthesis, shaded to the right. Bracket, or sorry, parenthesis, shaded to the left. And what we talked about is ands. What has to happen on an and? They got to combine, right? They got to meet. These two are never going to meet. They're going in opposite directions. Ors can go in opposite directions, ands cannot. So if I asked you what number is bigger than 2 and at the same time also less than -3, no solution. Yeah, it's not going to work. And you could just say no solution, okay? For this, I would say no solution, okay? And then because these two are not meeting, then you could just leave your number line blank, but because we start with the number line as kind of our go-to, then I would just put no solution there by it to say that there are no numbers in there that make that work. Okay, so those last couple were just a couple of different scenarios that could happen. Most of the time, it's going to be ands meeting, ors going opposite. Each one today is going to ask you to do these 3 parts, or most of the problems today are going to ask you to do those 3 parts, except for the first couple where you're just looking at some sets and determining the intersection and the union of those. Okay. Assignment for today. Going by 4, so we're starting at 10, and then 14, and then 18. Just keep adding 4 until you get to 82. Pay attention to your directions. Which ones are they asking to do, like all 3 parts to, just so you get some practice expressing all of those out.